All right, today we're going to look at 10.6, that is secants, tangents, and angle measure. And this is going to be arguably the second hardest thing, the second hardest section of the chapter. 10.7 is probably going to be a little bit tougher. And then we're going to end with 10.8, which I think might be one of the easiest sections of the chapter. So just a note about notes. You do need to take notes today. If you haven't been, you should be. But that is going to be your attendance today, as you're just going to post a picture of your notes onto Canvas. And that's going to be, again, your attendance assignment. It will be worth some points as well. So first of all, today, we're going to define what a secant is. And a secant is a line or segment or chord, something that is intersecting a circle in exactly two spots. Right, so it intersects a circle in exactly 2 points. This might be, if you want a little diagram of this, right, could be something like this. Again, or we could be talking about just a chord. So 2 spots or 2 spots. This is different than tangent because tangent intersects a circle at exactly 1 spot, right? Right, theorem 10.12, and we're going to take a look at a diagram of this first and see if we can't figure out what theorem 10.12 is going to tell us, so that it's a little bit more intuition based when you get to it on a test or a quiz than like having to know it, right? So if we have our circle, and we have 2 secants, just to make it very clear, this point is not the center. It is not the center of the circle. So if it were, things might be different, but we're going to say that it's actually not the center of the circle. We'll name our points, though, of intersection. We have A, B, C, and D. I'm going to call this point E again. E is not the center. And we're going to call this angle 1 and angle 2. So first, just as a quick review, there is something we know about angles 1 and 2. Angles 1 and 2 are supplementary because they're on a line together. I guess if we threw in one more thing, down here, if we had an angle 3, angles 1 and 3 would be congruent because they are vertical angles, right? So there is some stuff that's happening here. It's kind of like we're just adding a circle around a problem that we've already looked at before, at least here at the start. So the question then becomes, what do you think might be true about angle 1 or angle 3? In other words, how might we find the measure of angle 1 or 3? So I want you to think about it for a second here at least, and try to decide if you can't come up with some way. So your first thought might be that angle 1 has some relationship with arc AB, right? It's the intercepted arc of angle 1, and so maybe they have some relationship by themselves, right? But the problem there is that angle 1 and angle 3 have the same measure because they're vertical angles, and here it might look like they're the same, but I think if we were honest, it does look like AB is bigger, right? So that can't be what determines angle 1 if angle 1 and 3 have to be equal, but AB is bigger than arc CD, right? But it's a good step because it does involve arc AB, but it also involves the arc of its vertical angle, angle 3. So the measure of angle 1 is going to be equal to 1/2 the sum of those two arcs. So arc AB and arc CD. Again, notice that this means that that is also the measure of angle 3, right? The measure of angle 2 is 1/2. And can you figure out what we would do with this one? So if you thought maybe the measure of arc BC and the measure of arc AD, then you'd be correct. So it gets wordy. If you want the actual theorem written out in words, you can check your book for that. It says if two secants are chords, so we have two secants here, but it would be the same if the segments ended at B, C, A, and D. So if two secants or chords intersect in the interior of a circle, then the measure of the angles formed, like angle 1, is half the sum of the measures of the arcs of it, AB, and its vertical angle, CD. Right? Looking at some examples. It would brag about how good that circle looks, except that I know at some point in this video I'm going to make one of the worst looking circles ever, because I do that. All right, so if we had this diagram, right, we might find angle Y first, right? And angle Y is 1/2 the sum of its intercepted arc, 75, plus the intercepted arc of its vertical angle, which is 55. That's half of 130, which is 65. That means that X must be, well, X and Y are supplementary angles. So 180 minus 65, which is 115. If you didn't have to find angle X, if you were finding angle X by itself without ever finding angle Y, you could do it a different way as well, which would say the measure around a circle is 360. So if we wanted to find X by itself, we might say that X is 1/2 of 360 minus the two angles that don't go on the two arcs for X. So that'd be minus 130. That would be 1/2 of 230, which is also 115. So again, what that is doing, if I gave you this problem exactly, I would probably set it up the way that I did first. Did it again. Apologize. We're gonna work on this. So again, here x is 1/2 360. That's the measure all the way around the circle minus the two parts that we know that are not intercepted arcs of x or its vertical angle, right? That would leave us, if we subtract these two parts away, with the measure of this arc and this arc, which are those two arcs that we need for x. All right. Another circle. I'm not terrible, but it's not one that I would brag about. X, oops, X, 47 and 116. I'll give you a second there to think about your setup for this one. This one we just have an X in. X is 1/2 the sum of its intercepted arc and the intercepted arc of its vertical angle. (163), which is 81.5. I should probably have degrees there. All right, what if our setup was a little bit different? Ooh. You'd think the circles would get better, not worse. So what if it gave us that angle on the inside, right? It doesn't change anything, right? So the measure of this angle is 1/2 the sum of those other two angles, right? Now you could distribute here. I would suggest against it and rather just multiply both sides by 2. You get 256 is 154 plus x. Subtract 154 from both sides, you get 102, and x is 51. Which doesn't look right to me. Oh, because I'm an idiot. Why did I divide by 2? If you were asking yourself the same question, well, I was going to use the point that it's, did I not have it on the thing the whole time? All right, I'm going to continue to work on it. There, you probably couldn't even see my mistake then. So we have our circle here, and so we're going to set up it's the same. So 128 equals half of x plus 154, or 154 plus x. I multiply 2 by both sides and get 256 is 154 plus x. And then subtract 154 from both sides, we get 102. Okay? And then you don't do anything else, because that would be silly. All right. The next theorem is 1013. it deals with diagrams that look like this. All right, so a few things here. What would we call the segment AB? By definition, that is a secant. If you said chord, the segment AB is a chord. Technically, we have maybe a ray AB here, but it is a secant. It's going to intersect the circle twice. And then this line down here, or line segment, intersects the circle at one point, making it a tangent. And a thing that we can assume here is that they meet at point A. That point A is the point of tangency, right? So what do you think, or how do you think we might find the measure of angle 1? How do you think we might find the measure of angle 2? So while this doesn't always work, I'm going to simplify our diagram for us into one that I would strongly hope that we know. In fact, we already did it. Right? What if we had a tangent and a secant, and they were perpendicular to each other, right? Could you find the measure of arc ABC, right? Well, if it's tangent, it must be the radius. That means that this must be the diameter, right? And given that these are both 90, and arc ABC is going to be 180. 180 is twice of 90, right? So the same thing is going to work over here, in that the measure of angle 1 is going to be half of the measure of arc AB. It's an arc AB. And the measure of angle 2 is 1/2 the measure of arc ACB. Be careful, it is not ABC, right? Those are different things. ACB is A on the circle to C on the circle to B, right? ABC would be A going this way, B to C, which is definitely a different measure. All right. So again, think about this. A straight line has a measure of 180. 1 and 2 are supplementary angles, while around the circle is 360, right? So it's a relationship of 180 over 360. 180 over 360 is 1/2. All right, let's look at some examples of these ones. I was going to do them there, but I guess I'll do them on the back of the sheet. So these ones I think are a little bit easier than the last ones, mostly because they act like an angle that we already looked at this chapter. Oops. They act identical, or basically the same, I think identical, to an inscribed angle. And so we can kind of think about them that way. J, L, K. All right, so first question here, what's the measure of arc JLK? So JLK, and that's looking at the angle here, right, which is 116, is going around the circle, going to be longer, or measure bigger or smaller than 116. It's going to be bigger. It's going to be 2 times that, right? So 2 times 116, 232. Right. What if in the same diagram we wanted to find the measure of arc JK? So again, notice that JLK and JK are different arcs. JK goes from here to here. JLK goes around the circle this way, right? Well, we might want to find this angle first. We know that they're supplementary. So 116 plus 64. And JK is going to be twice of 64, which is 128. Again, notice 232 plus 128 is 360. All right, Theorem 1014. Theorem 1014. I'm going to draw 3 diagrams here, but in the end, we're going to view them basically all the same. There's a bad circle. A, B, C, D, E. Diagram 2. No, there's the bad one. That's a secant and a tangent. This was 2 secants. And this is where their intersection is happening outside of the circle. A, B, C, D. A, B, C, D. All right, when secant or tangents intersect outside of the circle, to find the measure of angle A, on the measure of angle A, what we are going to do is we are going to take 1/2, this is going to be the general for it, 1/2 measure angle A. So the measure of angle A is 1/2 the bigger or larger? Bigger. 1/2 the bigger arc minus the smaller arc. This is not how the book would describe it, but I think it's easier to look at because these are measures. So in other words, A in the first diagram here is DE, well, 1/2 DE minus BC. In the second one, it's 1/2 of DC minus BC. And in the third one, it's 1/2 of BDC, going around the circle this way, minus BC. All right. And that is, again, how it's always going to work. You could think about it also not as bigger and smaller, but the one that's further away from the angle and the one that's closer, further away and closer, further away and closer. So it's the one that's further away minus the closer one, and then you take 1/2 of that. Again, if you want a book definition of exactly what it says, you can look it up. I think it's easier to think about it this way, and it should make some sense. If it doesn't, feel free to email me and we can set up a time to talk about it. And then I can answer all your questions. And that's my worst straight line of the day. S, R, T, U. R is actually over here at the point of tangency. All right, so this is a straightforward one, right? The measure of angle S, S is an exterior point with a tangent and a secant. So it is going to be 1/2 the difference of the larger arc minus the smaller arc. we should get 54. Right. $68, 224, and that'll make it easier, X. Right? Exterior, or an angle outside, intersection outside of the circle between two tangents. Again, the measure, 68, is 1/2 the difference of the larger arc, the one that's further away, that's 224, minus the smaller one, the one that's closer, that is X. So we have two choices here. You can distribute, or you can multiply both sides by 2. I typically multiply both sides by 2 because I think it's easier. And we get 136. You get 224 minus X. Subtract 224 from both sides. You get negative 88. X is 88 then. Did I write something wrong? Either I wrote something wrong, or the problem I took from the book is wrong, and I'm just noticing that now. So whether you find this helpful or annoying, it fits a different problem we need to look at. And let's just double check to see if I did something wrong. The measure of the angle is 1/2 224 minus X. That looks right. Multiply by 2, and then we would subtract 224. The problem is that X should definitely be 136. Which means I think they have the problem set up wrong. And I don't think it's me. So I'll have to go back and see if I made a mistake here. How a problem like this would usually be set up. So if you want to, either box this and put a big question mark in it in your notes. You can write Mr. Poppy's wrong or something like that. I don't really care. There's something wrong in that one. And I don't think it's me unless I'm just missing it. This is the time in class where someone would usually tell me where I was wrong, and that would be helpful. Usually how this problem is going to look instead, which may be where I made my mistake. It'll be something like this. It's going to give you an angle measure in here, like, I don't know, we'll go with 54. And it won't give you either of these measures. It'll ask you to find one of them. Like, it'll ask you to find X, but it won't tell you anything else. So to find X in this diagram, what you would do is, you know what the measure of the rest of the circle is, right? The whole circle around has to be 360. So this part has to be 360 minus X, right? Because then when you take 360 minus X and add the other part of the arc, you get back to 360. And so here, 54 would have to equal 1/2 of 360 minus x minus x. Multiply both sides by 2, we get 108. 360 minus 2x. Subtract our 360 from both sides. It's 252. Negative 252. It's negative 2x. Divide both sides by 2. We get 126. If we were looking for the other part, the major arc, it would be 360 minus 126. Which would give us 234. Right? 234. So this kind of problem does come up every once in a while as well. And just trying to give you a basis there. Again, I need to go back and look at this one. I apologize for maybe wasting your time, but it did remind me to do this. I didn't have this one in the notes, so that should actually be helpful for you. And homework you should be able to find on Canvas. I can open it up here in a second. Page 746, numbers 8 to 23, that is all of them. I don't know if I'm actually on the screen or not. Okay. All right, that's your homework. That is due on Monday at noon. Monday at noon. Turn in the notes today. Okay.